everyone. So today we are going to start statistic. Okay, and to start with the statistic, first we need to understand what is a statistic. Okay, so statistic basically it's a branch of applied mathematics that deals with the data gathering, describing a data, analyzing a data, and drawing conclusion from the numerical data. Okay, and it is based on mathematical theories such as differential and integral calculus and linear algebra. Statistic is about using small sample size groups and observing their behavior to derive accurate conclusion about larger groups and general occurrences. Okay, this is a very general definition of a statistic, what we do in statistic. Okay, the small groups in a statistic are basically the subset of the larger group. Okay, now feature of statistic. Okay, the statistics are based on the theories of applied mathematics that we already have seen. Since deriving data from a larger group, okay, is a virtually impossible or requires too many resources, statistic uses smaller section of the larger group and uses it as a blueprint for the larger group. What it mean by in statistic has a two branch. First of all, understand, we learned about what is statistic. In statistic basically we analyze a data. Okay, we gather a data. Okay, and we draw a conclusion. Okay, conclusion can be of two type. Okay, what two type? First, what already happened. Okay, on with the help of that data particularly that we analyzed. Okay, and another thing is what can happen in future, that is another thing. Okay, so whenever we analyze the past data and we try to conclude what happened and why it happened, that type of branch in statistic is known as descriptive statistic. Okay, and whenever we descriptive means whenever we analyze a data, whatever we have gathered, whenever we analyze a data to conclude whatever has happened, why it has happened, what was the reason behind that. Okay, so when we analyze the data, historical data, to find the answer, okay, what has happened, then that type of branch of statistic which deals with such type of problems is known as descriptive statistic. Okay, whereas inferential statistic is another branch of a statistic where we try to predict for the future. We analyze the data, whatever we have gathered, okay, historical data, and we try to predict for the future what can happen. Okay, that where we deal with the inferential statistic. Also in inferential statistic we also deal with for the samples also. What sample here refers to means statistic we will deal with two type of thing. One is population and second is sample. What is population here? Population means the entire data. I'll show you the entire data. Okay, and sample is a sub part of that particular data. Like you have a cake, okay, and you take out a piece from the cake, a small piece, okay, of same cake. Okay, so that small piece of cake is known as sample of that particular bigger cake, and that bigger cake will be known as population. Okay, for example, what is the taste of that bigger cake? Okay, what is taste of uh, uh, what flavor it has? Okay, how good it is, good or bad. So to tell that information to anyone, we don't require to eat entire cake, do we? No, we don't require to eat entire cake. We will just take out a one piece from the cake, okay, and we'll eat and we'll tell the information to some other person about the entire cake, that the cake is good or bad, it is tasty or it is stale or it is fresh or it is creamy or it is what, it is chocolatey or whatever. So whenever you analyze a smaller set of data from a population means entire data, okay, smaller set means sample, okay. So whenever you analyze a sample to take out the inference means the result for the population, and you basically implicate that information for the population, that type of process or that type of branch which deals with such type of information is known as inferential statistics, where you deal with the samples and you take out some conclusion for the entire population, okay. For that, there is one more example that is written into the PPT that you can understand. For instance, a sneaker company, you can take any sneaker company, wants to know what are the 4 favored sneaker type among the youth of India, okay. There are a lot of models or items or categories in a sneaker, okay. So instead of asking every single resident of India, okay, whether what you like, what you favor, okay, they rely on a data such as survey and a pattern of a sale of different types of shoes. What will they will do, they will go on a market and they will do a survey and they will collect some small portion, not small but a big data, but not as big as entire India's population, right. They will bring us some data, and from that particular small data they will try to infer the information about total entire India's population, right. Are you getting my point? For another example, we had a COVID vaccine test in the starting. So whenever a company comes and says that we have 90% of success rate, we have 50% of success rate, we have 60% of success rate, right. So did that company came to you for the experiment and you said no, you said yes or no? No, we never did this type of thing. So what that company did, basically they took a sample, okay, they took a sample and they conducted experiment on that particular sample, okay, on particular those person, and according to the behavior and the result of the vaccine they concluded it for the entire population, okay. And there is a streamlined process how to conclude for a population, what are the steps, mathematics and tools that we use to take out a sample, how to infer it for the population. There's an entire streamlined process that we will study in the statistic. That's all is under the inferential statistic, but in short, long story short, this is the inferential statistic, okay, clear. Okay, so there are 2 types of statistic. One is descriptive and second is inferential, okay. Descriptive, where we try to analyze the historical data and we answer the question for the history only, okay, what happened and why happened, okay. Inferential, we analyze the past data to conclude for the future part, okay. That's what. And yep, so that's how we can't we can't analyze for entire population, we can't analyze for entire, because analyzing an entire big population, for example, if you want to analyze or conclude some information about India, so you need to analyze 1 billion population. It is very tough, it is very tough to analyze 1 billion population, right. So instead of analyzing this whole Indian population, we took out a sample which should reflect the Indian population, and we conduct our experiment on those particular small set of people, and then whatever the result has came, we will conclude for the entire population. Okay, so first we will start with the descriptive statistic. Okay, in descriptive statistic, will again it is divided into two things. One is measurement of central tendency and measurement of dispersion. Okay, we'll see each one of these one by one. In central tendency, we have mean, median and mode. Mean, mode and median. Okay, and again in the dispersion we have range, standard deviation, variance and interquartile region. Okay, so now we will understand each and everything in very detail about mean, mode, median, range, standard deviation, variance, interquartile region, covariance, correlation. Okay, everything. Okay, okay, fine. So let's jump here. Okay, so let's start our part for the statistic. Just it's not our okay, statistics. Okay, now so we understand what is statistic. It deals with the gathering, analyzing, describing and concluding a result over the data. Okay, we know it. And statistic is divided into descriptive and inferential, right? Very good. Now this was the division of statistic. Now we'll understand about type of data. If you receive data, okay, if you receive a data, okay, so on the basis of data we divide a data into two parts: categorical data and numerical data. Okay, again categorical data is further divided into two parts. First is nominal data and second one is ordinal data. Okay, and numerical data is further divided into two parts. First is interval data and second one is ratio variable. Okay, now we'll understand what is categorical data first. Okay, what is categorical data and what is numerical data? Okay, so categorical means when you have a data which is not a number, it's in a string format, like pass, fail, okay, man, woman, something like that. Categorical, some string format that represents a category, that is a categorical data, right? Now when you get a data which is a numerical in nature, maybe integer, maybe float, maybe complex also, like 1, 2, 3, 4.1, 4.8 and something, right? This is a numerical data, right? Now coming to the part, what is a nominal data, right? And what is an ordinal data? So nominal data is that categorical type of data where it represents a category but order doesn't matter. For example, red, orange, men, woman. So there is no order. Men should come first, a woman should come first, orange should come first, or red should come first. There's nothing like that, right? There's no order into this. But when you have a data where order matters, order matters, right? Like like executive, senior executive, right? Manager, AVP, VP, CEO, right? This is also in a string format. This is also a category. But don't you think here the order matters? The highest order should be given to CEO and the least should be given to the executive, and so on in between. Right? So whenever you receive a data where order matters, that type of data is known as ordinal data. Now coming to the numerical data. So when you receive a numerical data, okay, and in that numerical data, if you have meaning of 0 is not meaningful, 0 is not meaningful, or 0 is not 0 is not absolute. Like let's say take like absolute 0 is not absolute, and here 0 is absolute. Now what is mean by 0 is absolute or meaningful 0, or we can say meaningful 0. We can also say meaningful 0. So what is meaningful 0 and what is not a meaningful 0? For example, temperature in the interval data. Now it is measured on a scale. It can be Celsius or it can be Fahrenheit, right? So in this scale you might have a 0 degree also, and might have -1 degree also, and have plus 20 degree also. So it means 0 is on this scale, but it is not absolute 0. A number can be negative also and can be in positive side also. But in ratio variable, when you have 0, means you can't go into the negative side. It is a meaningful 0. There is absolute 0. For example, speed. For example, weight. You can have 0 speed, you can have 0 weight, but you can't have negative weight or negative speed. There's nothing after this 0. You can only go in this direction, increasing order. You can't move back, right? Yeah, here the 0 is totally absolute, means it's a meaningful 0. You can't go negative, like negative 20 kilometer per hour. Velocity can have, because velocity represents the direction also. It's a vector, right? So we are not talking about something in vector, right? Here we are only talking about the magnitude. Okay, so weight can never go into the negative side, speed can never go into the negative side. Okay, so that's how we represent. Okay, there are two types of data. In a broader way, we divide a data into categorical and numerical, then categorical nominal data, ordinal data, then numerical into the interval data and ratio variable. Okay, right. So now whenever we get a data, Okay, so whenever we get a data, okay, so basically we need to perform certain descriptive analytics. We need to perform some descriptive analytics. Okay, and what are those? That is, first we need to find mean, already shown. Second is mode and median we need to perform. Okay, second is we need to find the kurtosis and skewness, and third one is the central tendency. Okay, we will see everything in very detail now. Okay, what is mean, what is mode, what is median, what is kurtosis, what is skewness, what is central tendency, everything. Okay, now let's, for example, we get a data. Okay, we received a data. Okay, let us put a 2, 3, 8, 9, 16, 20. This is the data. Okay, now we need to find the mean for this data. The formula for the mean is summation of all the number upon the total count, means 2 plus 3 plus 8 plus 9 plus 16 plus 20 upon 1, 2, 3, 4, 5, 6. What will be the value? 5, 14, right? 20, 30, 39 plus 20, that is 49 and 59. 59 upon 6. So we could have done something else, like instead of 3, let us put, just for the easier calculation, yeah, nothing else, we want an easier calculation, right? 4, so that it becomes also 4 and it becomes 60, so it becomes 10. So this is our mean, right? What is median here, right? So median here refers to the, first, to find a median we need to sort a data. We need to sort the data. First is that sorting can be done in two ways, either by descending or either by ascending, doesn't matter. We need to sort the data. So already you can see data has been sorted, 2, 4, 8, 9, 16 or 20, in whatever way. The median is always a middle point. Median is always a middle point. Okay, so now you can see we have 2, we have 4, we have 8, we have 9, we have 16 and we have 20. Okay, for here, okay, for here, so don't you think if I take like this one and this one, again we are getting two values here. Okay, so whenever you find such type of thing, like whenever you have 1, 2, 3, 4, 5, 6, the total number is even or total number is odd, there can be two conditions. Okay, so first let's deal with for the odd condition. For example, you have 2, 8, 10, 20, 16. This is an odd value, right? It is sorted. Not sorted. We need to sort. So how to sort? 2, 8, 10, 16 and 20. Now it is sorted. Okay, so now you can see, you can divide the values, like this is first half and this is second half. So this is our middle value and this is our median. Okay, very clear for a data which is total count is odd. Am I clear? Very clear. But whenever you have a data where it is odd, even in nature, right, like this. So in that condition, what we will do, whatever two values are there in middle, okay, we'll take this one, we will do this summation 8 plus 9 upon 2. Okay, so 9 9 18, it will become 17 upon 2. The value will be how much? 8.5, right? So the middle value will be, median in this case will be 8.5. So you have both the condition. Now we'll move for the mode. Okay, we'll move for the mode. So what is mode? Mode refers to with the highest frequency, means any number or a value, that can be categorical also, which has highest repetition in data. For example, let's take one more example. For example, let's take 1 8 9 14 28 2 7 8 3 4, right? So now you can see here is a total random number. So let's see, 1 8 2 8 3 8, right? Do you have any other data? Right, okay. So 8 will be your mode. 8 will be your mode. Right, 8 will be your mode here. Mode can be 1, can be 1 and can be greater than 1 also. That is known as bimodal, when you have two modes, right? And multimodal, then two more than 2. Okay, it can have, that's not a issue in that. Okay, you can have it. Okay, we'll discuss about that one by one. Okay, so now descriptive means you look for the history, and inferential when you deal with the samples and future, right? Am I clear to you all? Okay, fine enough. So now we had all sorts of this type of descriptive analytics. Okay, now we will understand about a frequency chart. Okay, we'll understand about the frequency chart or frequency distribution. Okay, we'll understand about the frequency distribution. Now let's see, what is frequency distribution? So we know frequency here, especially frequency, if I talk about the frequency, so what it represents? It represents occurrence. Okay, it represents occurrence of any value in a data, right? Frequency is the occurrence of any value in a data. So just try to understand, if you have a dice, okay, now dice has 6 value: 1, 2, 3, 4, 5, 6, right? You threw a dice maybe 60 times. 60 times, right? Then you must be having some values for this, maybe 1, 2, 3, 5, 4, 5 and 6, okay? So for example, for 1 came around, for example, 10 times. 2 came around 15 times. So how much it happened? Total 25, right? 3 occurred around 14 times. Then again your 25, 29, okay, done. Then again it came around 10 times, 39, right? And it came around 5, okay, 39 or plus 5, that is 44, and it is 16. Then you have total 60, right? So now you can plot this graph, right, as a frequency chart, right? You can plot this graph. This is for 1, this is for 2, this is for 3, this is for 4, this is for 5, this is for 6, right? For 1 you have this value, for 2 you have this value, 3 this value, for 4 you again have this value, for 5 you again have this value, and for 6 you have this value, right? So I can say this is our frequency distribution, right? This is our frequency distribution. For the dice. When we threw that dice total 60 times, right? This is a frequency distribution, where here in y-axis it is representing frequency, and in x-axis it is representing dice ka value, right? Then so now let's move slightly more detail. I'm importing this value over here, okay, just a second. So let's import the value, okay. So let's use the same value as 1 is 10, 2 is 15, 3 is 14, 4 is 10, 5 is 5 is 5, 5 is 5, and 6 is 16, right? And total sum was 16. Done. So now before moving into this one, let's understand about a probability, right? What is a probability? So probability is a value which represents the likelihood of any particular value. What is likelihood? Means the chance of occurrence of that particular value. The formula for the probability is desired event by total event, right? This is the general formula for the probability, right? So now if I wanted to calculate the probability of 1, right, what is the probability of 1, what is the probability of 2, and so on for everyone, right? So we threw dice how much time? We threw dice for 60 times. So the chance for 1 or any number, let's take an example for the 1, the chance of coming 1 was total 60. The 1 can come for entire 60 times, can come. I'm not saying it will come, it is very difficult, it's next to impossible that every time you are throwing a dice and you are getting the same number. It's next to impossible, but chances are there, right? When you threw it for first time, you got 1, very good. Again threw, second time again 1, again, and whenever you are trying and throwing the dice, okay, you are getting 1 only. Okay, chances are there, although chances are very less, next to impossible, but chances are there, right? So the total chance for 1 was 60, but it came around how much time? 10 times. So our desired event was 10 and total was 60. So the probability of 1 will be 10 by 60, which will be 1 by 6, and that will be around how much? 0.22 something, right? Point, no, it will be 0.2, just a second, 10 ka 1, okay, 0.14, then 6 42, 6 6 are 36, right, around this much, okay. Then you have for this one, right, so this will be around 15 beta 60, right, this will be around 1 by 4, that is will be 0.25, this will be 14 by 60, 10 by 60, right, 5 by 60, and 16 by 60, right. Now all these values are what? Are the probabilities, right? Now if you want to, now just we are again plotting, okay, we are again plotting for 1, 2, 3, 4, 5 and 6, right? So whatever the value is, like, so whatever the value is, although the value will be the same, okay, the distribution curve will be the almost same, right, something, okay, whatever it is, okay. So now in the y-axis we are representing what? Probability, and here we are representing dice. And this curve, if this we join this plot as a curve instead of plotting a bar graph, since it's a discrete one, that's why you can also plot it as bar, but you have a continuous variable, okay, when you have a continuous, when when these are the discrete values, right? But when we have a continuous value, and you are plotting their probabilities of chance, okay, probability, right? Okay, then that type of chart is known as probability distribution curve. This is a distribution curve for the discrete numbers, okay, but we're talking about the continuous, for example. Okay, this is known as probability distribution curve. Probability distribution curve. Okay, am I clear to you? Okay, then that type of known as probability distribution curve. Now let me tell you about normal distribution. Now, when a probability distribution curve distribution curve takes a shape of a bell-shaped curve. Okay, it can be anything, but when it takes a shape of a bell-shaped curve, okay, we'll talk about this thing in very detail, like this way. Okay, this way. Then that type of probability distribution curve is known as normally distributed curve. Normally distributed curve, or in short, normal distribution. It's not necessary that it should always be like this. It can be in any shape, but when it takes a shape of like this, okay, and each value on this curve represents what? Probability, right? We have seen, na, these are what? Probabilities, na, right? So each and every value on a normally distribution curve represents the probability, because it is a probability distribution curve. It is a probability distribution curve itself, so it will represent the probability only, right? And that probability here we refer it as p value, probability value. We will talk about, don't worry, we'll talk about each and everything in very detail, okay? So normal distribution, when a probability distribution curve takes a shape of like this, then that probability distribution curve also comes up with some characteristic. Okay, it comes up with a characteristic. Okay, what is that characteristic? Okay, and how to understand? Okay, so we'll talk about everything. Okay, so some of the properties of a normal distribution curve. Since we talked about the probability distribution curve here, so I thought, well, let's introduce one type of probability distribution curve which is also known as normal distribution. It's a type of a probability distribution curve. Okay, it's a type. Okay, we'll talk about normal distribution in very detail. Okay, so it also comes up with some properties. When a probability distribution curve takes this shape, then it comes up with some properties also. Okay, what are those properties? First property is mean and median and mode. Okay, all are equal. Mean is equal to median is equals to mode. Now means whatever we have calculated here, the mean, this one, the median, this one, and the mode, right? And the mode. Okay, all value will be same. All value will be same. Okay, then we say it is a probability distribution curve. Okay, second thing is the standard deviation. Don't worry for this, I'll talk about this very detail. The standard deviation of this curve will be the width of the curve. Will be the width of the curve. It represents the spread of the data. Standard deviation or variance. Both represents what? Spread of data. We'll talk about this. Spread of data. Okay. Third, the curve is symmetric about its mean. Okay, the curve is symmetric about its mean. Symmetric means, now you can see mean, median and mode all will be represented at the center. Okay, this will be mean, this will be median, and this will only be your mode. Now you can see if this is your mean, this is the center. Okay, now you can see this side and this side both are symmetric, right? The curve is symmetric, and a bell shaped curve is always symmetric about its mean, right? Okay, so this is symmetric. And standard deviation is spread of data. Spread is how much? Now you can see from here the data is spread like this way, right? This is the spread of the data. Just a second. Okay, this is our spread of the data. Okay, this is the spread of the data. Okay, and total area under curve, total area under curve is equals to 1. Obviously we know that the probability, whatever the value we are getting, if we'll add, we'll get value 1 itself, because the sum of all the values in a probability is equal to 1 itself. The maximum probability can have be 1. So since this is the probability values, right, these are the probability values of different values that we have calculated, right, that we have already calculated. Okay, this corresponding are the p value. So now we will add all these p values of the corresponding x value, we'll get the value equal to 1. So if this is an area, this is a curve, and curve is having an area, okay, curve is having an area. Okay, so this area, if you will sum this area, will give the value of probability, right? Am I clear? Am I clear on? Okay, okay, the curve is asymptotic. What is asymptotic means? Asymptotic means when you expect a curve to touch the x-axis in infinity. Okay, that type of curve, or when you assume the curve will cross the x-axis at infinity. Now we are seeing this probability value is going, and it will touch this x value in some at some infinity value. Then that type of curve is known as asymptotic curve. Okay, that type of curve is known as asymptotic curve, and the last, mean is at the center. Mean is at the center, that we have already seen. Okay, so these are the properties. Okay, so just for one more information, we'll talk about this. Okay, just giving us some additional information. Since we have this y, this is y na, let's take this like this is y, right, and this is x. Okay, so now you have an x ka value, you have an a y ka value, you have an x ka value, you have an a y ka value corresponding, you have an x ka value, you have a corresponding y ka value. So now don't you think that y and x, y is a function of x, where here y is what, your probability, and x is your value. Okay, now whatever value you are giving, you are getting a probability ka value, and that you are basically representing here and here, right? Okay, now when this probability curve takes a shape like this way, this thing, then you take say it as a normally distributed curve, then you say, okay, very good. So now what is, how this is basically related? Y is a function of x. Now I'll not go into the derivation of this equation, but just for your understanding, okay, if y is the probability, then it is related by 1 upon sigma of under root 2 pi into e raised to minus of half into x minus mu upon sigma ka whole square. Okay, now here this sigma represents standard deviation that I told you. Okay, and this is formula for this probability distribution curve, this one. No, this is a probability distribution by no mean. Sorry, not binomial. Yeah, it's a probability distribution curve. Okay, this is probability distribution curve. Okay, there is a formula. When it takes a shape like this one, you will say the normal distribution, where sigma is standard deviation, mu is your mean, and here x represents your xi, the value. So for example, if you put this x ka value, you will get this y ka value. You put this x ka value, you get this y ka value. Getting my point? And whenever you have all the x I, y I, okay, let's x1, y1, x2, y2, and so on till xn and yn. Plot it. Okay, you will get the value curve. Okay, you will get the value of or the shape of the curve. Am I clear? Normal distribution is a type of probability distribution curve. Probability distribution curve is a curve when you represents a probability of any value. For example, this, right? But when this curve takes a shape of bell-shaped curve, okay, then you say that type of probability distribution curve is a normally distributed curve. Special case. Then only. Getting my point? Okay. So before going to that, we'll learn about something more special, like what is covariance, what is correlation, what is skewness, what is kurtosis, what is your standard deviation, what is your variance. Okay, we'll talk about these things now. Okay, that will help us in getting some knowledge also. Okay, then we'll again come to this probability distribution curve, and then we'll understand about all these things. Okay, for example, let's go back and let's learn about the first is covariance. What is covariance? Okay, now let's take an example. You have x data and y ka data. Okay, you have x1, x2, x3, x4 and so on. Here it is y1, y2, y3, y4 and so on. Now you plot both. Okay, or without plotting, you want to know what is whether x is related to y or not. Whether x is related to y or not means what? A relationship. A relationship. Okay. How x is related with y means if x is increasing, then what? Y is also increasing. Or if x is decreasing, y is also decreasing. There's one type of relationship, direct relationship. Now, or directly proportional, I can say. Then there's one more relation. When x increases, y decreases, or x decreases, y increases. This is indirect or inversely proportional. Okay, but this is a relationship, right? And there can be a no relationship also. Whether x increases doesn't matter to y. Y has a different way of increasing and decreasing. It is not related to something like x. For example, if I eat, the temperature of Bangalore increases. Is there any relationship? No, right? If I switch on my AC, the temperature of Bangalore decreases. Any relationship? No. Okay, that's how. Okay, there can be a relationship, there cannot be a relationship. For example, if Finance Minister of India introduces a tax or introduces a new financial bill into the Indian Parliament, then there is a chance that stock market either can go up or down according to the whatever the bill has proposed. So there is a relationship, right? So this type of thing, if there's a relationship or not, covariance tells us. Okay, covariance tells us about the relationship. Formula for covariance, for example, covariance of x and y. We want to find is there a relationship between x and y or not. So the formula for the covariance of x and y, any two column, is equals to summation of I equals to 1, say n xi cap minus x bar, okay, into y I minus y bar upon n minus 1. Okay, what is x bar refers? X bar is the mean. X bar here is the mean of x, and y bar is the mean of y. Okay, we already seen, right, how to calculate the mean part, right? Now this is the formula. Now let's take a question, okay, and let's find out the value for this one. Okay, then you will understand. Let's take the value for the x and let's take the value for the y. For x, let's take a very simple example: 12, 13, 14, 15, right? For y, let's take 2, 3, 4 and 5. right? So first, to find a covariance, we need to find the x bar and y bar. Okay, so let's put here. Okay, so let's find the value of x bar, like 12 plus 13 plus 14 plus 15. Okay, 1 2 3 4 values, right? And for this one we'll put 2 plus 3 plus 4 plus 5 upon 4. Okay, so x bar here comes up to be 30, how much, 13.5, and y bar will be around 3.5, right? Now we'll try to find the value. Okay, are you getting my point, everyone? Now let's find the value by this method. Okay, so, and the summation is there, so now what we'll do, we'll find like 12 minus of x bar, right? So 12 minus of 13.5, right? First into second value part, right? 2 minus 3.5, right? Then plus, so this is summation, right? Then 13 minus 13.5 into 3 minus 3.5, and plus again 14 into 13.5 into 4 minus 3.5, again plus 50 minus 13.5 into 5 minus 3.5, right? So this is our entire value. So what if we'll add all this value, how much it will come? Tell me. Right, this will be around minus 1.5, right, into again 1.5, right? Then plus this will be minus 0.5 into again it will be minus 0.5, and so on, right? So you will add whatever the value it will be there, and you need to n minus, how many values are there, 1 2 3 and 4, right? So whatever the summation comes, 3 minus 1, for example, let's take it as whatever the answer you got, answer 1 3 minus 1 will be your solution, right? So now if this value can be two things, can be negative and can be positive. Now if covariance of x and y comes to be negative, it means it is inversely proportional, means if x increases, y decreases, x decreases, y increases. But if this is positive, it means x increases, y increases, x decreases, y decreases. Are you getting my point? Okay, now yes, it is directly proportional when it is a positive, okay, and it is inversely proportional when it is negative. Okay, so now the limitation also you need to understand about the limitation of covariance also. Now you got the relationship, okay, it is positively correlated or negatively correlated, getting my point? But limitation is what? Limitation is covariance has no limit in value means its range is from minus infinity to plus infinity. It has no range. Okay, so you will get a relationship only. It is directly related or positively related. Okay, but how aggressively they are related, how positively they are related. For example, there is a two variable x1, x2, x3. Okay, getting my point? Now if I want to compare x1, x2 and x1 and x3, now both are relationship x1, x2 and x1, x3 is positive. It is coming around 500. It is coming around 1000 maybe. So from your perspective, you will say it is more highly related. It can be, right, and it can be less. No, it can't. You can't say. Really, you can't say, because it's all depend upon the values. Like for example, the value of this one. You're getting my point? All the value, how the values are coming. If the value after subtracting adding is coming greater, you'll get a value greater, but it doesn't signifies that is that much related to each other. Am I communicating? Okay, so what happens, it doesn't tell you that how closely it is related, how positively it is related. You can't compare two different values. Okay, you can't come, it has no limitation. It can go like it is 1000, it the even 1000 maybe. Chalo theek hai, if you can say around these two different variables. Okay, these two different variables. Okay, let's take it like that way. Okay, two different variable hai, you can say it is more. Okay, but in case like it is high or low. For example, let's forget about this. Okay, just take this example, 1000. So you can't say na 1000 is high, low or a medium, because you don't have a limitation. You don't have a reference. Means, yeah, means what? If you say like you have a particular value, for example, okay, right? This is end, this is end. Now you lie at this point. So you will say if I divide this strip into half, for example, if I divide this strip into half, okay, and you are standing at this point, okay, then you will say you are more towards the this let's take it like left and right. You are towards the right side, right? You are towards the right side, you will say, right? You are more approaching towards the right side, and you will say you are on the right side of the strip because you have a reference point, right? But if you don't have a line which is ending somewhere and you are lying at any point, you can't say you are at what point, whether you are at the middle point, whether you are at the lower side, whether you are at the higher side, because it doesn't have any limitation. It goes from minus infinity to plus infinity, and these all values come on the basis of more aggressive value. Means what? Let's take an example. Okay, if you'll have x and y like 1000, 1500, 2000, 2001, something like that, and here it is also like 5000, 2000, 8000, 8500 something. So obviously the value that you are going to get from this will be in 1000 or something greater, as compared to if you have value x and y in such like 5, 6, 2, 3, 1, 2, 8, 9, 6, for example. So if we'll compare this thing, okay, so obviously this value whatever you will get will be in one digit, and this will be in 2 or 3 digits or 4 digits itself. Getting my point? So you can't compare, like for example you are at this line, number line, right? It doesn't have end at this point, doesn't have end at this point, and you are lying at some point. You can't compare with, like you will say with the sign whether it's positive or whether it's negative. Positive directly related, negatively inversely related. That's only you will get from the covariance. You can't say how much related, how strongly related, because the value that you are getting from the covariance is just because of the number that I was trying to say from here. Maybe the way I was telling was not the correct, but still you understood what I'm trying to say, right? This, the value that you are getting is just because of the value that you have into the data, not it is an absolute value. You have a fixed reference, okay, ki if you get at this point you are at the higher side, you are highly correlated, and you are getting at this point you will be less correlated, or you are negatively, highly negatively or moderately negatively correlated. How strongly you are correlated, I got your relationship, but how strongly you are correlated, still I'm confused about that. Okay, so to resolve this, okay, to resolve this we have another statistical tool that we use to counter this, okay, and that we use known as Pearson correlation coefficient. Now this is one which not only tells about how strongly what type of relationship you have, it also tells us how strongly you are correlated or how negatively you are correlated. Okay, the formula for this one is, we represented like row xy. If two columns are there, you're finding the relationship between them, then the formula here stands for covariance of x and y upon the standard deviation of x and y. What is standard deviation? I'll let you know. Okay, don't worry for that. Okay, the standard deviation, okay, for both the axes. Okay, so now this correlation coefficient, Pearson correlation coefficient, has a very good value range. The value range starts from -1 and it goes to +1. It has a fixed range. -1 to +1. Now what if you get a value like something here that stands for 0.7, and you got some value like something -0.8. Now you can say, no, this is strongly correlated and this is strongly positively correlated and this is strongly negatively correlated, because you have a fixed point. You can't go beyond this and you can't go beyond this. You will have the value between x and y within this range. Now you can say if it is a positive, you will say you are directly related. If you're negative, you are inversely related, and with the value of that you will say how strongly you are related. Are you getting my point, everyone? Okay, so now you can say how strongly I am related to this one. For example, how strongly means this is x and this is y. Okay, these are the different values. If x increases by 2 unit, y also increases by 2 unit. That type of relationship is strongly related. Or somewhere like if x increases by 10 unit, y increases by 1 unit. So increasing is positive, x increases, y also increases, but in one case x, if even if x increases by 2 unit, y also increases by 2 unit, and in other case x increases by 10 unit but y increases by 1 unit, that is also a positive related. But are they strongly related? R is like if x changes a lot then y also changes a lot? No, right? So positive and negative represent the if x changes, y changes, but how much it changes, how strongly it is related, we get that information with the Pearson correlation coefficient with the values 0, no correlation. So we have one, we have given one like what I can say, some type of rules that if value is greater than 0.7 or 75, okay, then it is known as strongly correlated. Matlab it can be positive or negative both. Let me tell you like this way. Let's take it like 0.7 or 0.7 in negative, both, okay, strongly related. Okay, then you have a value, let me talk in the absolute term only, I'm not taking the any positive or negative. If the value is between 0.4 to 0.7 in between, then it is moderately correlated, right? But if you have values from 0 to 0.4 in between, okay, then it is no correlation, there is no relationship between them. Okay, so now let me tell you, if you have this is equals to relationship is equal to 1 correlation coefficient, okay, and you have this is positive 1, then you say this is x and this is y, it will increase like this in a straight line. But if you have this way negatively, then you will have a such type of relationship. If y decreasing decreasing, x is increasing. Okay, are you getting my point? Right, the data will be like this one, always the data will be around this way line. If it has is negative, y x is increasing, in this side and y is decreasing, that's why it's negatively. Okay, and so when you have no relationship, when you have a no relationship, then the data will be like this way. For example, let's say there is a no correlation, there is no relationship whether x is increasing or y is increasing or decreasing, there is no pattern coming up, right? So this type of is known as no relationship or correlation, right? No relationship or correlation. Okay, now we'll understand about standard deviation or variance. Okay, standard deviation and the variance. Okay, so as I told you, standard deviation and variance represent the spread of the data, spread of the data, how much the data is spread, that we represent with the value of standard deviation and the our variance. Now how to calculate standard deviation and how to calculate our basically variance. Okay, so now if you have a data, for example x, okay, now this x has a value like, just a second, so first let's talk about variance first. In first case we talk about the variance. Okay, we have data of x, represent x1, x2, x3, x4, x5 and so on till xn. Okay, now you want to know how much data is spread towards the from the mean, how much data is spread from the mean. Okay, so first you need to find the x bar, you need to find the mean, that is x bar. How to find? X1 plus x2 plus xn upon n, that is your x bar. Now what you need to do, you need to subtract each one with x bar. Okay, and so on. Okay, okay, now this provides the deviation, this provides the deviation, right? Okay, this first number how much is deviated from the mean, the second number how much it is deviated from the mean, third number how much it is deviated from the mean. Now this deviation can be positive, can be negative, both, right? Now every number has its own deviation, deviation 1, deviation 2, deviation 3 and so on. Now you want to know the mean of the deviation, like what is the one, tell me about one answer, how much data is deviated from the mean. Okay, because mean can be only one thing, this is x bar, this is one mean. Okay, so now for to that you will do what, you will add all the deviations, like deviation 1, or instead of writing deviation 1, let me represent deviation with d. Okay, so to get the mean will you represent d1, d2, d3 so on with dn upon n. Now try to understand, if you will add like this, if you will add like this, then you know this deviation can be positive or negative. So sometime you will see this is negative, this number is negative and this number is positive of same amplitude, then both might cancel each other, then the effect or the total deviation will not be, this formula will not represent the exact deviation. This is also deviated, this is also deviated, but once we add it, it got cancelled, right? It got cancelled, so it is not giving me the exact value. For example, let's take two deviation only, d1 plus d2. Okay, deviation is there, but this is -2 and this is +2, divide by 2, so minus plus 0, 0 by 2 equals to answer 0. So you will say this, the deviation, the mean deviation is 0, the mean deviation is 0, so the answer will be mean deviation is 0, means the data is not deviated, right? But do you think the data is not deviated? Data is deviated, data is deviated from the mean, right? If this is a mean, this is a mean, right? This is one deviation +2 and this is another deviation -2, right? So one data is here and one data is here with corresponding to the mean, right? So it is deviated, but since you added it like this way, it is giving 0 deviation. So it has a constraint, it has a, this formula has a constraint. To remove this constraint, what we do, we always square it. We always square it with, okay, we get the value from the squaring. Now you are getting the square any positive deviation always, and now if you will add it, this constraint what we had will be removed, and you will have a this which is known as variance. Means yes, so you can have xi minus x bar upon I1 to n upon n, right? So this is the formula for the variance. Am I clear to you? Right, this is formula for the variance. Now so you can say what variance tells. You have a different data. Now variance tells me if this is a mean x bar, how much data is basically away from the mean. This, how much data is spread from the mean. This is a spread, na? That's what we are calculating. Spread is the deviation. Getting my point? Am I clear? How much data is spread from the mean, the higher the deviation or higher the variance, means higher the data is spread from the mean. No, we are not talking about normal distribution here. We are not talking about okay, we are not talking anything about normal distribution here. We are just talking about the spread of the data. Okay, higher the variance means higher the deviation, because to get the higher value you need to higher denominator, right? Because the higher the variance, you need to higher the numerator, right? Higher the numerator, because denominator is fixed, total number of size of the data is fixed, right? Denominator is fixed, so you need to higher numerator. To get the higher numerator you need to higher deviations. Means the data point should be very far from the mean points, right? It means that there can be a possible case of outliers. We'll talk about the outliers also. Okay, and what is standard deviation? So standard deviation is the under root of variance, and it is represented by letter sigma. Okay, and variance is given by sigma cos. Yeah, for outlier I'll talk about in the next class, how to identify the outliers when you get this type of thing. Till now we'll complete the lecture till this point: standard deviation, variance, okay, covariance, okay, and our Pearson correlation coefficients, right? We'll talk about it. We'll talk about everything in detail. Okay, we'll take the each and every example and we'll talk about it in the next class. About the covariance, we don't use covariance. We use Pearson correlation coefficient always. We never use covariance, because covariance tells us about the relationship, positively or negatively, but how much it is related, it doesn't tell us. How much it is correlated, we get information about this type of information from the Pearson correlation coefficient only. Okay, where it has a fixed range of -1 to +1. Okay, ठीक है. So we'll talk. We'll now in the next class